The Wow Signal Podcast, a production of the Dream of the Open Channel. It's January 2013, and this is Episode 2, What About Fact A? Exploring the Fermi Paradox, Part 1.
Welcome. This is Paul Carr. In this episode of the Wow Signal Podcast, we're going to adopt a different frame of reference from Episode 1. In that episode, we considered seriously whether our planet has ever been visited by aliens, and what it might take to even understand that question, not to mention getting to its answer. In this episode, we will consider what it implies if the answer is simply, no, it hasn't been. In Episode 1, we spoke to Antonio Paris about his ambitious plans for reviving UFO studies. I think Antonio deserves respect and support for what he is doing, but there is a long way to go, and we don't know if we can solve the UFO mystery, if there in fact is a UFO mystery. This is the first in a series of episodes of the Wow Signal Podcast, in which we will take a hard look at the Fermi Paradox. And in this episode, we talk to award-winning science fiction author and NASA scientist Jeffrey Landis about his views on the paradox, what it tells us, and what we still don't know. Even determining what evidence we would need to evaluate whether Earth has ever been visited is a difficult problem, and what little data we do have has left the scientific community largely unconvinced. I personally do accept that there have been unidentified, maybe even anomalous things in our skies. But we have to watch out for the fallacious argument from ignorance. Just because we don't know what it is, doesn't mean it's an interstellar traveler. I think Antonio would agree. Now, this is not a UFO podcast, but rather a speculative science podcast. I like to think of it as applied hard science fiction. Hard SF is a subgenre of science fiction in which what we actually think we know about the universe plays into the story in some way, and things thought to contradict what we know scientifically are either absent or introduced very carefully. For the purposes of this series of episodes, we are going to take as a given the null hypothesis about alien visitors to Earth, that this hasn't happened lately and perhaps has never happened. This is what Michael Hart called Fact A. I'll also call it Fact A, but I really think it's more like Supposition A. We'll talk about the validity of this supposition in future episodes, but for our purposes now, we will assume Fact A is just that, a fact. It turns out that accepting Fact A presents an interesting dilemma, first recognized by the distinguished physicist Enrico Fermi in 1950. The unsolved problem is that we do expect alien visitors on our planet, given a set of very reasonable assumptions. It's really not such an extraordinary claim after all. The fact that no one can make a convincing case that they are here presents us with a puzzle. Either one or more reasonable assumptions have to go, or something weird is going on. Why is it a puzzle exactly? The problem is the vast timescales involved. Douglas Adams once said, "Space is big. You just won't believe how vastly, hugely, mind-bogglingly big it is. I mean, you may think it's a long way down the road to the chemist's, but that's just peanuts to space. But space is also hugely old. The entire history of Homo sapiens is only about 1/20,000th the age of the Earth, and the age of the Earth is less than a third the age of the universe. What would seem to be likely is that at least local to our galaxy, time eventually overwhelms space with respect to galactic colonization. Our galaxy is more than 10 billion years old, but is roughly 100,000 light years across. There are hundreds of billions of stars in the galaxy, and maybe trillions of planets. It only takes one civilization to arise in all this vastness, with the resources, technology, and persistence to initiate and maintain the process of galactic colonization. And they should be here by now. They should be done. You don't have to be able to travel faster than the speed of light or anywhere near it. You can illustrate this by taking a glass of water and putting 1 drop of food coloring in it. If you wait a while, the entire glass of water takes on the color of the food coloring. This food coloring and water analogy is called a diffusion model. The galactic process of colonization by diffusion would require colonists, either robotic, biological, or some of both, to maintain their momentum and motivation and to make use of local materials and energy, sending out new colonies in all directions. It would take somewhere between 1 million and 100 million years to colonize the galaxy this way. Even 100 million years is just 1% of the age of the galaxy. Even if you assume that it took several billion years for intelligent life to evolve anywhere, it's still only 2 to 3% of the available time to colonize. It doesn't appear that we have been colonized. In fact, we've been piecing together a reasonably good record of Earth's history and the history of our species. We're not done with that by any means, but so far, it can all be explained without resorting to colonization by aliens. Most of us don't think Earth is all that special, or that you would need a planet just like Earth to evolve life that can develop and use technology. We don't know this for sure, but it seems reasonable, versus the assumption that our planet and the pushy primates who dominate it are something really special on at least a galactic scale. Therefore, we would expect we are not the first civilization, and probably not the most capable, intelligent beings. So how do we account for fact A? It turns out that there are a large number of proposed solutions to this apparent paradox. Some of the most popular ones include: fact A is mistaken. Although we have already crossed that off our list for the purposes of this discussion, it is an explanation we will entertain in future episodes. Or advanced civilizations are so highly likely to self-destruct that they don't live long enough to colonize. Or advanced civilizations retreat into a virtual world and lose interest in the external universe. Or we really are the first technological civilization in the galaxy. Or we are the subject of a quarantine, or part of a galactic zoo, or interstellar travel is just too arduous and expensive that no one attempts it, and so on. Physicist Stephen Webb documented 50 proposed solutions in his book, Where is Everybody? However, most of these options assume that either civilizations colonize, or they don't, or if they do, they keep doing it indefinitely, presumably under some sort of central driving force or control. Does that really make the most sense? Jeffrey Landis had some thoughts about this, and in the early 1990s wrote them down in a much-cited paper for the Journal of the British Interplanetary Society. The Fermi Paradox, an approach based on percolation theory. Percolation is analogous to water trickling down through a sand or gravel medium. If the medium is loosely packed, then water will flow fairly freely through the rocks, and everything below it will get wet. If the medium is tightly packed and more solid, then water will flow more slowly and only into certain areas, and at least some of the area below will remain dry. It turns out there is a critical point where the medium is just loose enough, and almost all the water gets through and the area below gets soaked. Just a little more tightly packed, and there will be a few small dry areas below the medium. This is kind of like colonization. In the percolation model, if the probability that a civilization will colonize the next star systems is less than a certain critical level, there can be large voids of spaces not colonized, bounded by non-colonizing civilizations. This can be interpreted as each colony deciding independently if it wants to colonize more star systems or stay put. I asked Dr. Landis if he still thinks this is a good model for galactic colonization.
Yes, I think it's still a plausible approach to the Fermi Paradox. I do worry about a lot of the solutions that I hear people propose is that they really require a lot of uniformity on the part of extraterrestrial civilization. It could be that some civilizations die out because, for example, global war, but it's hard to think that all civilizations have exactly the same problem. So I really was sort of working on looking at the approach that allows for different civilizations to be different. A question that you sort of have is how much biological determinism is there? So one of my key assumptions was that a culture changes. So if you have a colony that's far away from the parent, it will have its own culture. So if you're a great believer in biological determinism, then it's not, we'll say, well, so what? The parent culture and the colony will be the same. But I'm not sure if I'm really a great believer in biological determinism.
Of course, this leads us to ask, where does the drive to colonize come from? And what may cause its strength to vary from colony to colony?
Well, I think that's really a very open question. Even with humanity, you certainly hear a lot of visionaries talk about the exploratory urge of humans, but actually the main urge, I think, of humans is to, stay home and not do anything. Exploratory urge, I think, is a subset. But the question is there enough of a subset of the species that's going to go out there and do that? And I think probably there is. Certainly some fraction of the people are going to want to say, well, I'm not satisfied staying at home. I want to go out and explore new worlds and find new civilizations or found new civilizations. So if the resources are there to do colonization, I think that over a long enough time period, it's likely to happen.
I see. So let's just talk about the human future then. Assuming we can get off the planet permanently and colonize our solar system, do you think there's some probability, it may not be one, that some subset of humanity will ultimately at least start the process of colonization?
If we can make a truly interplanetary civilization, and that has yet to be proven, but if we can, I think that sooner or later, perhaps hundreds of years, perhaps even thousands of years later, but sooner or later, I think that somebody is going to want to make the jump to the stars. There's a lot of technology that needs to be developed to do that.
Oh, yeah. We're not ready to do it now. This 100-year Starship project, are you involved with that at all?
Yeah, I've been involved a little bit. I'm not part of the Mae Jemison Foundation, but I certainly went to the kickoff symposium and made a couple of presentations.
Finally, what does fact A really mean? Dr. Landis, like any good scientist, steers us away from epistemic hubris. But fact A really does speak to the difficulty of interstellar travel.
Isn't that important data? It tells us something about how civilizations behave over the long term.
Tell us something. It's hard to figure out exactly what it tells us because there's so much that we don't know.
That's true.
It would tell us that interstellar travel is not easy. Because if interstellar travel were easy, if the faster-than-light drives and the warp engines science fiction is so in love with were easy to make, then it's virtually impossible to think that we could be in an area that had not been visited thousands of times by many civilizations over the past billion years. So I would almost say that the Fermi Paradox itself, the fact that we have no evidence of having been visited, is pretty good evidence that interstellar travel is not easy. It is not evidence that it's impossible, but it can't be easy, because if it were as easy as Star Trek would have it, they would be here first.
And now, here is modern jazz composer and saxophonist Jason Robinson with an excerpt from his composition Radiate, featuring Liberty Ullman on guitar. That was the latter part of Radiate by Jason Robinson from his new album on cuneiform, Tiresian Symmetry. I love the way the whole band goes charging towards the end, furiously, under control, but only just. That's one of the good tracks. Well, they're all good tracks from Tiresian Symmetry. You can learn more about Jason and his music at jasonrobinson.com. We'll have links in the show notes. So let's sum up. Looking at it with a simple model, one explanation of the Fermi Paradox is a combination of the difficulty of interstellar travel coupled with a limited drive to colonize that will vary from culture to culture. Percolation theory tells us that if the probability of colonization is low enough, there will be voids surrounded by non-colonizing societies, and these voids could be quite large. We might be living inside one of those voids. Now, the actual complexities of galactic colonization are greater than we can readily model with tools we have at hand, whether it be the diffusion equation or the random graph theory used to make sense of percolation simulations. Some of the complexities involve the cultural and biological complexities of the colonization drive and how it may wax and wane with time, competition and even conflict between colonizing cultures, the rise and fall of advanced civilizations, and the apparent likelihood that advanced technologies would offer mind uploading, or that highly advanced sophonts would be pure information beings. As Paul Davies discussed in his book, The Eerie Silence, highly advanced sophonts may even have mastered something beyond information that we don't even have a concept for. They might travel the universe on beams of neutrinos or something even more exotic, with little need for spaceships or physical colonies. One thing I think is likely in all this multidimensional speculation, there are complexities to the Fermi Paradox that we haven't thought of yet, and perhaps even can't think of. In future episodes, we will explore some of the solutions to the Fermi Paradox, ordinary and exotic. What we want to know is, how does the best science we have constrain these solutions, and how and where shall we look to test them? Testing many of them is presently beyond the state of the art of what we can observe now, but that shouldn't stop us from dreaming and planning. We will also look at fact A itself. Maybe it's not a fact. How could we know? There are real problems with this, and we will break those down and try to understand each one, with a view toward understanding how we could turn fact A into a hypothesis we could really test. In my view, the lack of a flying saucer in the Smithsonian isn't very interesting or illuminating either way. Now a bit about the Drake equation. There are a good many online resources and books about the Drake equation, and I will provide links in the show notes, so I will just give you the executive summary, since I want to refer to it often in upcoming episodes. There's nothing exotic or alien about the math in the Drake equation. It's just 7 factors that, when multiplied together, should yield a good estimate of the number of civilizations in our galaxy capable of communicating with us. When I was in college, we had at best a handle on the first factor, and now we have respectable estimates of the first 3, with astrobiologists working hard to understand the 4th. So, 3 down, 4 to go. But as you work from left to right in the Drake equation, the factors get harder and harder to estimate. We may be a generation or 2 away from even a rough estimate of the 4th factor, which is the probability of life arising on a suitably Earth-like planet. All we know for sure is that none of these factors are 0, because we're here. The big question is, how much larger than 0 are they? Is the Drake equation related to fact A? Only indirectly. The Drake equation estimates the number of independently arising civilizations presently in the galaxy. It does not take colonization into account. Instead of food coloring diffusing throughout the glass of water, it's a number of tiny globules of different colors floating and suspended in the water, but not mixing. Here's some more music by Jason Robinson, the saxophone-based duet from the beginning of Cosmolography, the last track on Taresian Symmetry. This features Drew Gress on bass. That's Jason Robinson, an excerpt from Cosmolography. Go to the show notes at wowsignalpodcast.blogspot.com for links to Jason's music and to Cuneiform Records. I hope you'll all consider picking up that CD, Taresian Symmetries, and listening to the entire thing for yourself. Now, a few announcements. First, I want to encourage listeners to visit the podcast blog at wowsignalpodcast.blogspot.com and leave your thoughts about this episode in the comments to the show notes. In addition to your thoughts on the content, please let me know how the podcast can be improved and what features or guests you would like to hear. If you are a musician and would like your music to appear on the podcast, I'd also like to hear from you. Also, please leave us a review on iTunes or Miro. I'm looking for panelists on two topics: human space colonization and Bracewell probes. Please see the blog if you are interested in participating, or email to wowsignalpodcast@gmail.com. My regular blog is disownedsky.blogspot.com, and I also encourage you to visit there, where many of the same topics are covered. You can also follow me on Twitter at Paul D. Carr. That's Carr with 2 R's. I want to add a regular feature of listener interviews on this podcast, during which you discuss your thoughts on the topics covered in previous episodes. So if you have any thoughts or questions on the episodes 1 or 2, email wowsignalpodcast@gmail.com, and I will call you up and we'll record a brief conversation that may be featured in episodes 3 and 4. The next episode of the Wow Signal podcast, episode 3, will feature a conversation with futurist blogger and Singularity one-on-one podcaster Nikola Danilov, who has talked to almost everyone in the futurist, transhumanist, and singularitarian communities. We'll cover a wide range of topics, but our emphasis will be the near-term future of humanity, and also the likely trajectory of any technologically sophisticated sentient race. That should be out in early February 2013. My thanks to Jeffrey Landis, Jason Robinson, Sleep Research Facility, and Joyce Abba for their contributions. Thank you, and I hope you'll keep listening. Here's an excerpt of Stealth 5 by Sleep Research Facility to take us out.
This has been Episode 2 of the Wow Signal Podcast. The spoken content of the Wow Signal Podcast is distributed under the Creative Commons Attribution Share-alike 3.0 license. All music is presented with the permission of the artists. Please see the Episode 2 show notes for details and links at wowsignalpodcast.blogspot.com.